and welcome to another WJEC A level question. This is question 6 from May 2015, Unit 1. This question about moments. The first part of the question says, explain with the aid of a diagram what's meant by the moment of a force about a point. So I've pre-drawn this diagram. The definition of the moment of a force is that the moment of a force is the force multiplied by perpendicular distance from a pivot. So in terms of the diagram, it would be that the moment is equal to F times R. You can put that in words, but as long as you've got the right angle on the diagram, that's fine. So I'll just sort of emphasize the perpendicular bit here. The reason why I've used an R rather than something like a D for the diagram is that an R sort of looks a bit like a right angle. For the next part of the question, we've got a classroom projector set up as shown, so we can see the projector here on the right with a weight of 22 newtons. It's on a long sort of beam, a uniform bar, uniform meaning that the centre of gravity is in the middle, and this bar's got a weight of 12 newtons, and there's a support strut here making an angle of 40 degrees, as you can see on the diagram. We're going to take moments about the hinge, and we're going to show that the force F is about 200 newtons. So what might make this a little bit easier to see is if perhaps I extend this force here. So if I just sort of extend it that way a little bit there, we've got to remember that when we're taking the moment of a force, the moment of this force F needs to be this force F needs to be perpendicular to this 0.4 meter distance. So what we would do here is resolve the force into this direction here. Now if we think carefully about angles, we've got a 40-degree angle here, we've got a 90-degree angle there, so this final angle at the end must be 50 degrees. So if I just add that to the diagram. So this vertical component of the force here is going to be either F cos 50 degrees or possibly, if you prefer, F sine 40 degrees. Both will give exactly the same answer. So now we can take moments about the pivot. The sum of the clockwise moments must equal the sum of the anti-clockwise moments. Clockwise, we've got this 22 Newton force at a distance of 1.8 meters. We've also got the 12 Newton force acting through the centre of gravity, which is in the middle of the beam and hence at a distance of 0.9 meters from the end of the beam. Remember, the whole length is 1.8 meters. Anti-clockwise, we got our F cos 50, and that's at a distance of 0.4 meters from the pivot there. So a bit of rearrangement. F is going to be 22 times 1.8 plus 12 times 0.9, all divided by cos 50 times 0.4. If we put those numbers into a calculator, we end up with just over 196 newtons. So 196 newtons will be fine for our answer. The question continues by drawing a free body diagram below showing some of the vertical forces acting on the uniform bar. And for part 2, part 1, we've got to calculate the vertical component of the force exerted by the strut on the bar. In other words, we want the vertical component of F, which is simply, as I've labelled here, F cos 50. So we've got our 196 cos of 50, and that gives us an exact answer of 126 newtons. So let's just add that to the diagram. Next, we need to indicate with an arrow on the diagram the direction of the vertical force on the bar due to the hinge. Well, the other condition for an object to be in equilibrium, apart from the fact that there must be no resultant moment about any point, is that there must be no resultant force in any direction. We can see on the diagram at the moment we've got a lot more force pointing upwards than we've got downwards. So the force on the hinge must be downwards, and I'll call it FH for argument's sake. And finally, to calculate the size of that vertical force on the hinge, we just realise that the sum of the upward forces must equal the sum of the downward forces. So therefore FH is going to be 126 that we got upwards. Take away those 2 downward forces, which will give us 92 newtons. Thank you very much for listening. Please remember to like and subscribe, and feel free to comment below. Goodbye.